Hello class, it is Mr. Lehman, and today we're going to take a look at two questions to start out, take a look at two answers to some page 6 problems that you did for homework last night, and then we're going to take notes top half of page 8, and then you're going to work on ChemQuest 5C today for the bulk of today's class. So we have two questions to start out, so I just want to sort of walk you through my thought process here and how you should be attacking problems like you see on page 6. So first question says, which atom is larger, magnesium or phosphorus? And the second question says, which atom is larger, neon or argon? So my clue is use the periodic table. You got to use the periodic table. The periodic table is your best friend. So, and then once you're looking at the question, like circle the elements you're comparing. So we're comparing magnesium to phosphorus. So right now, make a prediction in your head, pause the video, think it through, and then unpause it. Alright, welcome back here. We're going to take a look at the answer. And so magnesium has 3 shells of electrons, 12 protons, 12 electrons. It has 2 electrons out here in the third shell. Those are the valence electrons. And then phosphorus has 15 electrons. It has 5 valence electrons. So notice they both have 3 shells of electrons. So you might be thinking a couple of days ago, like, oh, they're the same size. Or maybe phosphorus is smaller because it has more protons, or actually maybe phosphorus is bigger because it has more electrons. What is going on? Well, you have to remember the ENC. The ENC is the effective nuclear charge. It is the force of attraction of the nucleus to those outer electrons. So because there's 12 protons, there's a plus 12 charge in the nucleus trying to pull in the electrons. But every inner electron, called a core electron, is able to block or shield the outer electrons from that charge. So because there's 10 inner electrons, that'll block out 10 of the positive charge, and that means that the effective nuclear charge is like plus 2. So these valence electrons are being pulled in with a weak plus 2 force. For phosphorus, phosphorus has 15 protons, 15 electrons, but only 10 of those electrons are found in the inner shells. So you take 15 protons minus the 10 core electrons, which will block out 10 of that charge, and the ENC is a much stronger plus 5. Alright, so yes, there's 3 shells of electrons for each, but because the electrons are being pulled in phosphorus with a bigger charge with more force, phosphorus' nucleus, singular, phosphorus' nucleus is able to pull those electrons in closer to it, and that'll make phosphorus smaller. So phosphorus is the answer for that one. The second question asks you to compare neon to argon. This one's easier to explain. So neon and argon, family members. They both have plus 8 ENCs, but neon only has 2 shells of electrons, argon has 3 shells of electrons, and so because those electrons are being pulled in with the same force, argon's going to be bigger. So argon would be bigger because it has 1, 2, 3 shells. It has an extra shell of electrons, and so the electrons are going to be farther away from the nucleus, and that'll make it bigger. Back here, this one, magnesium was the bigger atom, and this was the smaller. So that is the trend of size. This chart in your notes, once again, as you go down the periodic table, they get bigger, and as you go across the periodic table, they get smaller. Bigger because we're adding extra layers of electrons, smaller left to right because the ENC is increasing. The pull from the nucleus is increasing, pulling those electrons closer. Alright, so my students had you label the ENC values for the 8 main group families. And so, Mr. Rafferty students, if you have not done that yet, it's very helpful. So, group 1 elements will have a plus 1 ENC, a plus 1 pull. And these are for neutral atoms. These are not for ions. These are for neutral atoms only. Group 2, plus 2. Group 13 will pull their electrons in on the outside with a plus 3 force. Group 14, 4 plus. Group 15, 5 plus. Group 16, 6 plus. Group 17 has a plus 7 ENC. And then group 18 has a plus 8. Now I did highlight I highlighted helium because helium only has 2 electrons and 2 protons. So helium is actually only plus 2. So there's an exception there in that family. So here's some answers. I know I put my answers up for my students. Mr. Rafferty, if he has not done so already, he will today. Put answers up to page 6. So question 4, this is ultimately what I'm going to be able to ask you to do come test time, quiz time. So I'll give you some elements, and you got to look at where they are on the periodic table and put them in order from like smallest to largest or largest to smallest. Typically we go smallest to largest. So let's take a look at like this one here. So question 4A, how did I come up with this answer key? Well, I look at that, and I find the elements in the periodic table. Let me erase this. That's for the next one we're going to look at. In question 4A, look, we had sulfur, aluminum, magnesium, and sodium. So just look there, they're all in the same row. So for us to do this, things have to be in the same period or same column. It's really hard to compare things that are diagonal because we have conflicting information. So it's all about the ENC here. They all have 3 shells of electrons. It's how strongly those atoms are pulling in those electrons. And so sulfur would be the smallest of the 4 because sulfur is pulling in its outer electrons with a very strong +6 charge, whereas sodium would be the biggest because it's pulling its outer electron in with the weakest +1 charge. So the bigger the ENC, the closer the electrons could be pulled. All right, let's take a look at 4C, 4F. I'm sorry, 4F is a little bit harder because we're going to have things in the same column and same things in the same period. So we got neon, oxygen, sulfur, selenium. So here are those 4 elements highlighted on our periodic table for question 4F. So the question is, which one is the smallest? And the answer is neon. All right. So we have things here, oxygen and neon. They only have 2 shells of electrons. Sulfur has a 3rd shell of electrons, and then selenium has 4 shells of electrons. So what I like to do is look at these 3 and save neon. So look at the 3 in the same family and say, in this family, oxygen is the smallest, and selenium is the biggest of the 3. And then once you figure this out, then compare neon to oxygen. They both have 2 shells of electrons, and because neon is pulling in those electrons with a stronger force, a +8 ENC, it is going to be smaller than oxygen. So we know that neon would be the smallest of the 4. So that's my strategy. If you have things that form an L in the periodic table, do the vertical column first, and then look at the horizontal period, or do the horizontal period first, and then the column. So look at these. You can't compare things that are diagonal to each other directly. All right, just a little bit of advice there. All right, so continuing on here, quick joke. 2 flasks are sitting there talking to each other, discussing life's problems, and here's what is going on. So seriously, dude, I think you're overreacting. Good chemistry joke right there. Look, he's reacting. We see bubbling. We see gas being released. Ha-ha. And here's 2 elements are watching and listening to that joke. This is what they say. That was sodium funny. I slapped my knee on that one. That's a good one right there. All right, let's continue on. We're going to turn to page 8 in our notes. And just one little topic today before we get into ChemQuest Class C, and that is, we talked about atomic size earlier in the week. Now let's talk about what happens to atoms, their size, if they gain electrons and become a negative ion, an anion, or if they lose electrons and become positively charged, which is called cations. And so letter B, once again, we're top of page 8. We're just going to do letter B, 1, 2, and 3 today. Ionic size, number 1. I'm going to cover up this bottom half for now. So number 1, when atoms gain electrons, when they steal electrons from other atoms, they will become negatively charged. And as a result, they will get larger in size. Their diameter, their radius will increase. The question is why? Why do atoms get bigger when they gain electrons? And here's the reason why. If you add extra electrons to an atom, now there's more electrons in the same energy level. If there's more electrons in the same energy level, and you're not doing anything different, those extra negative charges want to get away from each other, right? Electrons are all negatively charged, and they repel each other. So if you add another negative electron to the outside, it is going to repel from the other electrons, and they try to equalize that by spreading apart. Just like magnets, if you put magnets too close together that have the same charge, you let go, they try to spread out, right, to minimize that force of repulsion. Same thing is going to happen here. So I like to think of this as a 4-step problem. All right, so you add more electrons, you gain more electrons, what happens? That increases the force of attraction. The force of repulsion. I misspoke. That increases the force of repulsion for those electrons on the outside. So what happens as a result? Step 3, those electrons are going to spread apart. Well, what happens when electrons spread apart on the outside? That causes them to get farther away from the nucleus, which will increase the size of the ion. So add more electrons, that increases the repulsive forces between the negative electrons. As a result, the electrons are going to spread out, push apart, and that will increase the size of the ion. All right, here's an example of that. So fluorine. Fluorine has 9 protons, 9 electrons. So here we go. But if we add in an extra electron, fluorine can steal. Fluorine is the best non-metal at stealing electrons. Fluorine will steal an electron from a metal, and now look, it now has an extra electron. The proton number is the same, so the ENC is the same, all right, +7. Fluorine's pulling in those electrons with a +7 pull, but because we're adding an extra electron, there's now greater repulsive forces. The electrons want to push apart from each other with greater force, and that is going to make the fluorine ion, the negatively charged ion, -1 ion, be a little bit bigger. All right, number 2, B2, notes. When atoms lose electrons, they will become positively charged. And as a result, they will get smaller. There's a big reason here. One thing is there's fewer electrons. There's fewer electrons, there's going to be fewer negative charges repelling each other, and so the electrons can get a little bit closer together. But the big reason, the huge reason is there's fewer energy levels, right? We're going to see that metals will lose 1 or 2 or 3 electrons to basically lose all those outer electrons to become more stable, like the closest noble gas. And so if we lose 1 electron, and we only have 1 electron on the outside, now you have 1 fewer energy levels, and that is going to make an ion, a positive ion, get much, much smaller. So that's the biggest reason. Fewer energy levels makes ions get much, much smaller. So let's check this out. So lithium is element 3 protons, 3 electrons. It has a very weak +1 pull on this electron on the outside. So other atoms can come along, steal this electron very, very easily, and that leaves lithium with a +1 charge. All right? That leaves it with no more 2s1 electron. Right? It has 1s2, 2s1. The second energy level s electron is now stolen. All it has left are the 2 electrons and the 1s. And look how much smaller it is, right? There is no more second energy level. All right? So the radius from the nucleus to the outermost electron is much smaller. All right? And then if you go down a family, ions will get bigger for the same reason that ions get bigger for normal reasons. For atoms to normally get bigger for normal reasons, because we're adding additional shells of electrons. So for instance here, let's compare family member sodium to family member lithium. Right? Lithium, element 3, very small. Sodium, element 11, pretty small too when it's an ion. But look, it's going to be bigger than lithium. That's because it has a second shell of electrons. And those second shell electrons are going to be farther away than the first shell electrons. All right, so that is today's notes. I hope you have a great day, everybody. Go work on ChemQuest 5C, and that is due before the start of next class. And because our next class is an asynchronous Monday, it'll be due start of Tuesday's class. And then you also have another assignment coming up for asynchronous Monday, so tune in Monday to Canvas to find out what you'll be working on that day. All right, have a great day, everybody. See you.